for being socially isolated where it truly quote-unquote counts. That's certainly possible, and I think that's a follow-on study that would require a different design than we had. But the interviews we had suggest that that if that is the case, it's probably in a minority of the players, but who knows for sure. Next slide. So a few minutes ago, I talked about this idea of mapping, the idea that, you know, behavior in the game might map to behavior out of the game. Our very first test of this was in just, you know, totally lateral thinking. Was to check out economic behavior. Do, in fact, the people in the game world behave economically the way we would expect them to behave offline? Does that behavior, that kind of game theoretical approach, does it work? And the nice thing about the virtual world is that unlike the real world, we get all the data. Now, everybody, of course, you've been following the news, knows that GDP and inflation and bank rates, I mean, these things are about as topical as they could possibly get. But almost all of the measures that we use on the national scale are, in fact, estimates. When we calculate GDP, you know, the different government departments will, for example, call up car dealerships and say, how many cars did you sell? And get the number from them over the phone or through an electronic report. So we don't get actual perfect data. We just get estimates of everything for the baseline stuff we use. And it's probably pretty good, but the virtue of doing this stuff in a virtual space, pardon the pun, is that you don't have to have an estimate of everything, of anything. If you just want to say, hey, what was the cash flow in the space last month, you just know it. So if you wanted to test inflationary pressure and you wanted to see, well, how much cash is flowing into a society or out of it, you would know an answer and show how it varies over time, which is a nice thing to be able to do. So the first thing that we wanted to test was, all right, can we create a GDP and can we see relative price levels? Can we create price indices and GDP levels? Next slide. And this is kind of a proof of concept here. This is just one server, and you know the y-axis is money, and shows a GDP rate and a price level. And so a couple things are notable. Number one, we could do it, which was exciting for us just to be able to calculate these things. This is crunching all the data from a month into one data point, which is pretty computationally intensive over a few 100,000 people. The other thing that's notable is that the two things track closely together, so it makes sense. It should do what you'd want to do. Price levels and GDP go up and down with each other. The other is that there's some fluctuation there. The price levels and the GDP levels really jump up and down quite a bit from month to month. And when we collected these data about 8 months ago, we'd say, you know, this never happens in the real world. But I don't use that line anymore, because the volatility we found in the virtual space, maybe it does map a little better than we thought it might to the offline space, which is sad but potentially true. Next slide. Okay, now if you folks are like me, you have moderate background knowledge about supply and demand, which say you need it explained to you and you kind of know what's going on. It's basically all explained through something called the quantity theory of money, which shows that changes in the number of people buying something, the amount of money that's floating around out there will predict how much something costs. And so if you look at changes in money supply and you look at changes in population, you should be able to make predictions about price. And that ought to apply in the virtual space if there's mapping the same way that we know if it works offline. So what this chart here shows, the pink line shows the changes in money supply that were floating around the virtual world. Where in February, there was this much money, and in March, the amount of money went up and then went back down again. The blue line shows how many people there were playing. In February, there were X number of people, and then March, there was a big nosedive. I don't know what's going on in March. Maybe it's finals or something. Who knows? And there's a big drop down, and then it goes back up again. So March is this really interesting month in the data where there's more money but fewer people. And if the people in this game world work the way we think they would, we should be able to make a pretty obvious prediction about what will happen to prices in the month of March with a lot of money but fewer people. The prices should spike in March. Next slide. And in fact, that's exactly what we find. We find that the price level has this random spike in March, and it's totally predicted by these two factors about money supply and population. So this is a really fun, geeky moment for those of us with some econ bent on the team. And I think it's also proof of concept that there is this macro mapping level effect in economic behavior. And it shows potentially that we could use virtual spaces, you know, a lot of caveats here, as test beds for something like monetary policy. Why is that interesting? It's a whole lot cheaper than a $1 trillion stimulus package is one reason it's potentially interesting. I'm not saying we ought to, run the U.S. by this, but doing cheap or relatively free tests in a virtual space might be a nice way of testing unknown behaviors over time. Next slide. So something else that was interesting to us was the extent to which these behaviors might be particular to a given server or particular game, or they might be just the idiosyncrasies of a given population or a culture. And one way of testing that would be if you could take the United States and you could copy it and you could flow into the US, into this empty copy, into this kind of control condition, an equal number of people who are just like the people in the US. And see, did they behave the same way? Did they make the same banks? Did the prices stay the same? And in a virtual space, you can actually do that because sometimes they make copies of the game worlds when there's a population change. So when one server gets too busy, they'll realize, okay, we've got too much player demand, not capacity. They'll make a copy of the world, they'll bring it online, and they'll say, who wants to come onto this one because it's emptier? And so there's like an immigration kind of thing going on. And what this chart here shows, if you look at the pink line and compare it to the blue line, the pink line is an existing server, and the blue line is a new server that they create from scratch, and they bring it online at the beginning, the end of January actually. And so the test of this behavioral pattern is, will the blue line catch up to the pink line and start to match it, or will it be different on its own if you do make this, in fact, copy of the United States? And so what we see is that it takes about 2-3 months and the blue line starts to match the pink one and starts to track along with it really nicely. What this suggests to me is that the code and the mechanics of the game have a very strong impact on the behaviors, so much so that you can barely distinguish one population from another, which is a really interesting test of the sort of replicability and the power of code over human behavior. I've got findings on networks. I don't know, Jimmy, how are we doing on time? I could do a couple minutes on this, but if it's, I don't have a clock or anything, so I don't know what time's left.
I'd say you can go with what you like. We've actually got the room for quite a while longer, so the questions can go over a little bit if we need to. I'd say you could take a few minutes if you like, Dmitri.
Okay, all right. Let me breeze through the network findings. These are findings primarily from my colleague Nosh Contractor at Northwestern. I'm less expert in networks, but just enough to get into trouble. I like to show them because I think the networking approach is particularly powerful, and we have great network data from these game worlds. So you guys have all seen these kind of hub and spoke graphs. I'll show you some of them. We can construct those because we know who groups with whom, we know who talks to whom, we know who trades with whom. And it's really hard to collect those data in the real world, whereas here we just have them all, and we can build out these maps, which is pretty cool. So I'm going to show you a cartoon, and the cartoon is going to be illustrating the idea that, well, go ahead and read the cartoon first. Right, so the cartoon is a reminder that even though we're going into these spaces and we're playing with these people in remote locations, not everybody's in a remote location. Some people are playing together, and some people are playing close by. It's not necessarily a total collection of random strangers. One of the interesting questions to us was, if you go into this game, are you playing with people you know, are you playing with people nearby you, or are you playing with people like you, or are you playing with these random strangers? Because, there's that first wave of internet research which is all about, these spooky people online, and what are they going to do, and, they're going to molest our kids and all this kind of business. The subsequent waves of research have really toned that down quite a bit. We realized that the online world is much more supplementary, complementary, and coordinating for offline behaviors. And so here's a way of testing that. Next slide. These data are just from a few days of the servers from 3,000 players, and you can see demographically where they show up in the United States. There's a little intensity map there on the right. We have, in this particular slice of the data, their gender, their age, how long they've been playing, and then where they are, because we have their zip code. We also have their ISPs, so we can actually plot where they are by their ISP as well with, I'll show you in a minute. Next slide. Here are 4 graphs for 4 different kinds of behaviors. The top left is a graph of partnership. Top right is instant messaging, that is sending a message just from one